Okay, so welcome back to my channel. Okay, so welcome everyone. So today we'll continue our journey. So for today we'll see how to use the power rule. Okay, the power rule of integration. So integration. So today we revise how to use the power rule of integration. Okay, so it's actually very simple. There is a general form. So for example, you have a function f of x equal to x to the power n. Okay, so how do you, and we say integrate this function. If you integrate this function, okay, so if you integrate this function, so you say x, you're adding the power. So this is just the difference. I mean, the only difference with integration and the differentiation is differentiation, you drop the power and subtract by 1, but here you divide, I mean you add the power and divide by the same addition of the power. So there are kind of two different types of integrations. So there is an integration where, for example, if we integrate, we say y equal to, we call this indefinite. Indefinite integral. Okay, so why do we call it indefinite integral? It's not bounded. So it's not bounded. It's not bounded. Okay, so in short, it does not have limits of integration. So it doesn't have limits. So then there is also another form where they give you, for example, y equals to integral, let's say a b x to the power n. So this should be dx here because we are integrating with respect to x dx. Okay, so this one is called a definite. Definite integral. So why definite? Because it has limits of integration. So we call a lower limit. So a is a lower limit in this case. The one at the bottom is a lower limit. So a is lower limit of integration. Then b is called upper limit. Upper limit of integration. Okay. So so if you have a function, you are integrating a function and you don't have limits, you add a plus c. After finding the answer, you add the plus c to show that this function doesn't have a limit. But if you have limits, you just substitute the limits at the end. Okay. So I think you should know that. Okay, now, so we have functions. We have how many? 4. Okay, 4. So we're told to integrate. So we are integrating negative 3 x to the power 9 dx. Okay, so very simple. So integration, we know this number is called what? This is the coefficient. A number in front of a variable. So a variable, these are letters y, it can be a, it can be c, it can be d, it can be x. These are variables. So a number in front of a variable is what? A coefficient. So in integration, we take out the coefficient because it doesn't affect the the solving. So if we write negative 3x to the power 9dx, we just take out the constant. This is a constant here. It doesn't affect our integration. So we just rewrite it like this. Okay, dx. Okay. Next. So we are adding the power today. So we can open our bracket here. We say x 9 plus 1 over 9 plus 1. Okay. Plus c. Don't forget to add the plus c because this one doesn't have a limit. So we say negative 3 to be x to the power 10 over 9 plus 1, 10 plus c. Oh, there is a negative here. Okay, so there is a negative here. So this is your answer. Negative 3 x to the power 10 over 10 plus c. So the integral of negative 3 x to the power 9 dx is equals to this. Simple and straightforward. So you add the power and divide by the same addition of the power. So if you have numbers, you take out the numbers during integration because these are constants. Whether we keep them here, it's the same, but it shows mathematics when you take it. So you gotta look cool. You look cooler. Okay, so you take out the number. So if there was 10, we could take out the 10 with a sign, whether it's positive or negative. We can take it out so that we only remain with a variable here because we are just interested in the variable. Okay. So let's go to part B. So part B, I posted the lesson on indices. Indices, you just need to revise some rules of indices. Okay, so rules of indices. Is what we call positive index. So for example, x to the power 1 over 2. The power is positive, so this is a positive index. Positive index. So this indices is what is positive because the power is what positive. But if we write x to the power negative 2, the power is negative, so this is negative. Okay. So another tricky thing which you have to know is how do you convert, for example, you have a negative power, how do you convert it to positive power? And if you have a positive power, there are forms of rewriting a negative index, so converting the negative to positive. So I say x to the power negative 2. If I want to write this as a positive index, I'll write 1 over x to the power 2. This and this is the same thing. So if I have 1 over x to the power negative 2 over 3. Let me write positive here. Okay. Just quickly remove it so that. Okay, so let's say we have this. This is the same as x to the power negative 2 over 3. So you guys have to know that how do you convert from negative to positive? You divide 1 by the whole number x to the power 2 over 3. So the negative is here. Okay, so let me write a couple of more. So you have let's say x to the power negative 2 over 5. Okay, so you rewrite this as a positive index. It will be 1 over x to the power 2 over 5. Okay, great. Now you know. So when it's like this, you can't integrate. It will be difficult to integrate. So you need to rewrite it in this form. So this will be same as x to the power negative 2 over 5. Like this is very easy because you just add the 1 here plus 1 and then this plus 1. Very simple. So you gotta know, like if you have 1 over something here, you just add the negative to the power. Also, you need to know these things. Let's say you have x to the power 2 over 5. This can be rewritten like this. So you have x here. So this denominator comes here, 5. Then the numerator comes here. So you gotta know, oh, this, what does it mean? How does it mean? So this just means x, the numerator is here, so you know it's 2. Denominator is here, over 5. Okay, so this is just a square root form of indices using a square root. Okay, so we can write more. So I can say x to the power 2 over 3. Okay, so how can this appear? X will go inside the bracket, then denominator will come here, and the power will come here. So this is a cube root. It means cube root, meaning numbers which the same number you multiply itself 3 times, it gives you x. This is what it means, cube root. Okay, so if it's like this, you have to interpret it in this way. You need to be able to convert it to this form, because when you convert it to this form, it becomes easy to integrate. So let's say you have a 4 here, you have x. This one, how can it be? Okay, great. So you have x, the power, meaning the power here is 1. So the numerator will be 1 over denominator 4. It will be 1, x is 1 over 4. Okay, let me write a couple of more. So let's say x is 3 here, and then there is 2 here. Okay, so meaning this is x, the numerator is here, the power of x is the numerator, so this is 2. Denominator is the one here, so 3. Okay. Okay, so hope you guys have understood how we convert these functions. So I was doing it in preparation of this one. So b, since we have revised, b we have integrate 5 over, so that is 4 here, x to the power 3 dx. Okay, so let's rewrite this as a fraction. It will be, okay, so we have 5 integrate, so x, the numerator is 3, so you have 3 over, denominator is 4, okay, dx. Great. Okay, we've done one thing. Next, I've said we can take out the constant. 5 is a constant, so let's take out the 5. We'll have 1 over x to the power 3 over 4 dx. Okay, so like this, I said it will be very difficult to integrate this. When you want this power, how do you convert this power to negative? This one means 1 over this. It means you just take out the power, you convert the power to negative. So this is the same as 5 x to the power negative 3 over 4 dx. Okay, so remember from here you have this. Now you want to write it in this standard so that it becomes easier to integrate. So you have, this is a positive index. How do you take it to negative? Just multiply, you know the power, there is 1 here, the power, you just multiply the power by negative, or just add the negative to the power, denominator, become like this. Okay, so now it has become very easy. So we have 5, we open our bracket. So how do we integrate? We say x, you add the power 1 over 4, you add 1 over power, which is negative 3 over 4 plus 1. It doesn't have a limit, so don't forget a plus c. Okay, so great. Let's do a little bit old school mathematics. So we have 3 over 4, you're adding 1. So you can say this is over 1. Find the common denominator of 4 and 1. A number which can go into, where 4 can go into and 1. So this is 4. 4 into 4. This is 1. 1 multiplied by negative 3, we have negative 3 plus 1 into 4, 4. 4 multiplied by 1, this is 4. Okay, so negative 3 plus 4 is 1 over 4. Okay, so we know the power will be 1 over 4, even at the denominator 1 over 4. Okay, so great. Let's quickly write that 5. So x to the power 1 over 4 over, even here it will be 1 over 4 plus c. Okay, so if you see what is in the brackets, so you have 5, then brackets. So in the brackets we have x divided by 1 over 4. This is the same. This divided by this. Okay? So let's simplify it further. Don't want anyone to be lost. So x to the power 1 over 4. Then we get rid of the division. So the numerator becomes the denominator. The denominator becomes the numerator. So you have 4 over 1. Okay. Plus c. I didn't want to just to jump and then 4 is up, then others will be lost. So we have 5. So now this is 4x to the power 1 over 4. Okay. Over 1 is just the same, plus c. Okay. So now 4 multiplied by 5 is what? 20. X to the power 1 over 4 plus c. So this is your answer. So the integral of 5 over square root of how was it? Okay, 4. This is 4 here. 4x to the power 3 dx equals to 20 x to the power 1 over 4 plus c. So wherever you are integrating and you don't have limits here, you always add the plus c to show that it's an indefinite integral. Okay, let's continue. So we go to c. Okay, so part c is quite simple. Part c is quite simple. So you have root of x to the power 5 dx. So you rewrite this, those who remember. So this is what is this? So you write x. Where is the denominator? Where is the numerator? So here, what's the numerator? The numerator, where is it? So you follow this path. Here. So this here becomes the power here is the one which is the denominator is this one which is here, then the numerator is the power. Okay, so now let's come here. So what's here? There is nothing, but this is a square. It means a square. So meaning you have 5 over 2 dx. Okay, so if you have something like x to the power 1 over 2, so you write a square, but we can't write a 2 here because this 2, we know the denominator is 2. We can't write it here because this already means this square, x to the power 1. Okay, so if you have x to the power 5 over 2, you write a square root. So what's the denominator is 2. So we only write numbers from 2 going up, like maybe 2.1, 2.2, we would have write it here. But this is 2. We can't write 2 here because this means square root. We've already written the 2. So just write x to the power 5. Okay. So hope this is not a confusion here where this 2 is coming from. Okay. So write another one. Let's say x to the power 3 over 2. Okay, so this you write square root x. The denominator is 2. We can't write it here. 2 we can't write because why don't we write 2? This already means a square, so it will be just like this. Okay, so this is it. Okay, now we apply the power rule. We add 1. There is no coefficient this time, so nothing to take out. So we say x 5 over 2 plus 1 over 5 over 2 plus 1 plus c. Okay, so this equals to, let's do a little bit of odd mathematics. So we have 5 over 2 plus 1. So this is over 1. We find a common denominator, which is 2. So finding a common denominator, just multiply the denominators 2 and 1. 2 by 1, it is 2. 2 into 2, 1. 1 multiplied by 5, 5 plus 1 into 2 is what? 1 into 2 is 2. 2 by 1, 2. Okay. 5 plus 2, which is 7 over 2. Okay, so we know the power will be 7 over 2. Okay, great. So let's continue from here. So x will be 7 over 2 over 7 over 2 plus c. Okay, so let's rewrite this in a fancy way like we did for the previous one. 7 over 2. This is divided by 7 over 2 is plus c. Okay, great. Okay, so let's carry on. This is x 7 over 2. We do away with the division, so the numerator becomes the denominator, the denominator becomes the numerator. So you have 2 over 7 plus c. Okay, so this is the same as, this is over 1, so this multiplied by that, it will be 2x to the power 7 over 2. 1 multiplied by 7 over 7 plus c. So this is your answer. So the integral of x to the power 5 dx equals to 2x to the power 7 over 2 over 7 plus c. Okay, great. So let's go to another question. So we have d. Okay, so part d, we are saying integrate c dx. So what is c? C is a constant. So a constant can be natural numbers, -1, it can be integer, any integer. Okay, -2, -3, it can be 1, it can be 2, it can be 4, it can be 5, any number. That's C. So how do we integrate now? We don't have x here. What do we add? We only add the powers of x. Now here we don't have x. How do we solve this question? Okay, so you say c power dx. So we take out the c. I said c is a constant, so we say c dx. Okay, so what you should know is, you remember from our previous discussion, any variable to the power 0 is what? 1. So we know there is 1 here in front. 1 multiplied by dx. So we'll use this relation to say x to the power 0 is what? 1. So meaning there is x to the power 0 here. Okay. So meaning you have c x to the power 0 dx. It's the same because x to the power 0 is 1. Okay. So c, now we have x 0 plus 1, okay, over 0 plus 1 plus c. So we have c, then 0 plus 1 is 1 over 0 plus 1 is 1 plus c. So this is same as power 1. We don't write power 1. So this is just cx plus c. So this is a little bit confusing. We can use any data. Okay, so I don't know why they set this question to plus c, but at least to differentiate, it's supposed to be any letter. So c can be any number. So it could have been a at least, so to differentiate with this one, the standard of integration. Because we can't have two c's, meaning we have to solve, we need to factor out c. No. Okay, so let's see. Okay, I've written this c as small, this one as big. Okay, but you know, you understand. So quick tips. Quick tips now. Okay, so you just have to know these things. If you are integrating, let's say there is 2, integrate 2 dx, you just add x to it. It's 2x, because it's a constant. 2 is what? A constant. No need to start writing x to the power 0. You know now. Okay, so if I say integrate 20 dx, you know this will be 20x, because you know x to the power 0, yeah, formality. But if you are quick, you don't have to solve these things. You just quickly have to just say, oh, this is this. Okay, then let's say you are integrating so integration, if you have a function x to the power n dx, you're integrating, this is same as x, you're adding the powers. So if you don't have limits, this is indefinite integral. Okay, then if, for example, I want to do one with limits, so let's say integrate 0 to 1 x to the power 2 plus x minus 10. So everything is dx. So let's try solve this one. So this is same as you are integrating each term. So this is same as 0 to 1 x squared dx plus 0 to 1 x dx minus integrating 0 to 1 negative 10 dx. This is what it means. Okay, so this is just a bonus question for you guys. Okay, so here you're adding the power, so it will be x 2 plus 1 over 2 plus 1. Great, mind you, so you write 0 to 1, you're integrating 0 to 1, plus here you're adding, so x power 1, so 1 plus 1 over 1 plus 1, 0 to 1. Okay, minus, this is a constant, so integrating a constant, you just add x, no need to waste time. So this will be 10x, 0 to 1. Okay, so let's continue. This will be x to the power 3 over 3 plus, this will be x to the power 2 over 2 minus 10x. Okay, so everything is 0 to 1. So these are limits of integration. Now we substitute the limits. So you first substitute the upper limit minus lower limit. So it's upper limit minus lower limit. Okay, so now where there is x, everywhere where there is x, we'll put what? 1. This is our upper limit. So you have 1 over 3. This is power 3. Okay, so we have 1 to the power 3 plus, where there is x, put 1 squared over 2 minus 10 where there is x 1. So this is the upper limit minus, so lower limit is 0, so you say 0 to the power 3 over 3 plus 0 to the power 2 over 2 minus 10 to the power multiplied by 0. Okay, yeah, so now we rewrite this. So we have 1 over 3. 1 to the power any number is just 1 plus 1 over 2 minus, this would be 10. Okay, 10 minus 0 to the power 3, so it will be 0 over 3 plus 0 over 2 minus 10 by 0. Okay, so we do all the mathematics here. We can use body mass, brackets of division, multiplication, addition, then subtraction. So we'll start with addition, the body mass, brackets of division, multiplication, addition, subtraction. So we'll start with these. We'll add them, then subtract 10. Okay. So let me just rewrite it. 1 over 3 plus 1 over 2 minus 10. This is our upper limit minus. So this is 0, this is 0, this is 0. So 0 plus 0 plus 0. Okay. So we'll start with this addition. We're following body mass. So 1 over 3 plus 1 over 2. So common denominator here, you just multiply 3 by 2, 6. Okay? 3 into 6, 2. 2 multiplied by 1, which will be 2, plus 2 into 6, 3. 3 multiplied by 1, 3. So this is just 5 over 6. So this will be 5 over 6. Okay? So I'll continue from here. So this, it will be 5 over 6 minus 10 minus 0. Okay. So next, let's subtract this. So you have 5 over 6 minus 10. So this is over 1. Okay. So common denominator, 6 multiplied by 1, which is 6. So 6 into 6 is 1. 1 multiplied by 5, 5 minus 1 into 6 is 6. 6 by 10, 60. So 5 minus 60, which is negative 55 over 6. Okay, so this will be negative 55 over 6 minus 0, which is just equal to negative 55 over 6. This will be your answer. So we don't do any plus c here because we had limits. So your answer is, let me write it nicely, negative 55 over 6. Okay, so now we've finished. So today we've revised the power rule of integration. So you guys solve as many questions as possible. Continue following my page. Okay, invite more friends, invite more family members. Okay, I will continue trying to help you guys with your problems. So I advise, if you have any challenges, email me, call me, or comment the topic which you would want me to revise on. So I will incorporate a lot of things. There will be software trainings. Yeah, so there will be there is a lot coming. This is just the beginning. So thank you and have a pleasant evening.